Alright, so we're back here with another video. This one's going to be on rectangular coordinates, graphing, and circles. As you can see right here, there's the section objectives listed right here, 1 through 6. The first one here, graph two variable equations in a rectangular coordinate system. Just whenever you see rectangular coordinate system, it's kind of a, I don't know, not a new word, but it's kind of weird. Just think XY coordinate plane. It's kind of easier to just think of that like we're used to the X's and Y's. That's what rectangular coordinate system is. The second one here, it says find the distance between 2 points. So we're going to be finding the distance. That's going to be the distance formula that we're going to be going over later. The next thing, it says determine the midpoint of 2 points. Again, on that XY coordinate plane, there's going to be a midpoint between any 2 points, and we're going to be finding that using the midpoint formula. Next, we're going to use standard form of equation of a circle, and that basically tells us certain things about the circle. We're going to be using those certain things that we learn about on the circle to do the next part there where it says graphing circles. We're going to graph circles. And then the last one, gain familiarity with some basic graphs. We're going to be doing that with like linear stuff, quadratic, cubic, that sort of thing, as well as just, graphing circles as well. All right, so the first thing we're going to go over is that rectangular coordinate system, also known as the Cartesian coordinate system, or again, just the XY coordinate plane. Same kind of thing. It says right here, consists of two perpendicular lines intersecting at their 0 marks. Okay, the 0 marks in the two perpendicular lines is just the x-axis and the y-axis. So if you know, here's the x-axis, here's the y-axis, and if you notice, they intersect at perpendicular lines at 0, 0 right there. The number lines are called axes. Horizontal is typically the x-axis, vertical is the y-axis. Hopefully you have at least heard of that by now. The horizontal axis increases to the right, the vertical axis increases upward. So if you notice, the y-axis, it's positive values going up, and then going to the right, it's positive values. And then the opposite obviously is occurring with negative going down and negative going to the left for each of those axes. A point on the rectangular coordinate system is a pair of coordinates x comma y that indicates a location relative to the x and y axes. The point of intersection of the number lines is called the origin, 0, 0. We kind of colored it in red in the center right here. That's the origin. So that's basically kind of a quick review of what the rectangular coordinate system is. Again, the XY coordinate plane, same kind of thing. A point is a solution of a two-variable equation if substitution of the coordinates for the corresponding variables yields a true statement. So we're going to go over those solutions with intersections a little bit later. The next thing, it says the graph of a two-variable equation is a collection of all the points that satisfy the equation, and all those 2 points are the x and y coordinates basically, and that's what forms basically that graph. For now, we will determine the graph of two-variable equation by finding several solutions, plotting them, and then hoping they provide a representative sample, so you kind of can guess what the rest of the graph would look like, and then generalizing to the overall graph from that sample. So this first one right here, it says find 5 points that satisfy y equals x minus 1, plot them, and then sketch the graph. So this is what I highly recommend you do anytime it says to graph something, sketch a graph, anything like that, is you want to make what's called an XY table. So there's my X, here's my Y, and I made a table basically, and I'm going to fill these in with certain values. One value that I like to start with for my X, I call this like my home base, is anything that makes the Y 0. Okay, so if I put a 0 in for this Y, what X value would make that Y 0? Well, hopefully you see it's X minus 1, so it's 1 minus 1. So now you have 1 for your X. Okay, so that's my home base where Y is equal to 0. The next thing I'm going to do is just pick values that are to the left and to the right of x equals 1. For example, left of 1, there's a 0 for x. To the right of 1, there's a 2. So it's 0, 1, 2. So those are all by that home base value of 1 on either side of it. It does say for 5 points, so I'm going to go 2 away from it as well. So I'm going to also go with negative 1 as well as 3. Okay, so 1 is at the center. To the left of it is 0, to the right of it is 2, to the left of it 2 spots is negative 1, to the right of it 2 spots is 3. And then from there, I'm just going to plug it into the y equation to get those y values. So here x is equal to 0, so I'm going to put a 0 in for x here. 0 minus 1 is negative 1. Okay, I'm going to do the same thing with the 2, plug in the 2 where the x is, and it's 2 minus 1, that's going to be 1. Okay, I'm going to do the same thing again with negative 1. I'm going to plug negative 1 into that x equation, the y equation, but I'm going to plug it in for x. So negative 1 minus 1 is negative 2. And then you plug 3 in as well for that x of the y equation, and you get 2. Okay, now that I have those 5 points, those 5 coordinates, I can just graph those. Okay, so 1 comma 0, that's the x is 1, the y is 0, so that would be right there. Okay, the next one, 0 comma negative 1, that would be 0 for the x, negative 1 for the y, so that'd be right there. You can already see from those 2 points that if you wanted to, you could just make a line with those. 2 comma 1, I'm actually going to try to highlight this so it makes a little bit more sense for each of these graphs. So now the highlighted colors will match the points on the graph. So the yellow, 2 comma 1, 2x, 1y, right there. The next one, negative 1, negative 2, so negative 1, negative 2 right there. And the last one, 3 comma 2, 1, 2, 3, up 2, like that. And you end up with those 5 spots right there. And it's to sketch the graph. So we're going to use the trend that we see here to just basically connect the dots. It's not going to be exact, you know, if you connect the dots, but it doesn't really need to be. Just do the best you can. And that's basically the sketch of the graph. Okay. So found 5 points, plotted them, and then sketched the actual graph. We're going to do the same thing on the next one as well. Only this one's actually in standard form. So the one we just did was in slope-intercept form. That's what this y equals x minus 1 represents, slope-intercept form. This one, though, is going to be standard form. And there's a little bit easier way of dealing with these, especially since it doesn't say that it needs 5 points. It just says find some points that are solutions and then sketch. So you only need actually 2 points for a line. So that's what we're going to do. We're going to make our XY table like we did before, and we're going to fill in this case, we're going to put 0 in for X and 0 in for Y, and then to solve. Now what's great about doing this is it makes the equation super easy to solve. So if X is 0 right here, you can just get rid of it, and then you just have 2Y equals 4, divide both sides by 2, Y is equal to 2. And then you just put a 2 there. Okay, let's see here. I'm going to do the same thing again. Let me rewrite the equation. So x plus 2y equals 4. Now the second part, this part right here has y equal to 0. So that means this whole thing is gone because y is 0. X has to be equal to 4 then. So now we have our 2 points, 0, 2 and 4, 0. I'm just going to graph those and basically, or plot those, I'm sorry, then just make the graph based on those plots. So this first one, I'll just do green. So 0, 2 would be right there, 0, 2. Okay, 4, 0. 1, 2, 3, 4, 0. You have something like that, and then we're just going to basically connect the dots here. I basically just use the digital ruler right there to make it a straight line, just, I don't know, so it's kind of nicer to see. But anyway, that's that one. I found some points that are the solutions and then sketched the graph, and that's how we got them. And again, the easy thing that you can do, just kind of like a little cheat code, plugging in 0 for X, solving for Y, plugging in 0 for Y, solving for X. You know it still works as the solutions. It's just easier with the zeros because the math comes out easier. Now, if you wanted to, you can use 1 and 2 and, you know, -1 or something like that, but it's just easier to use those zeros. So hopefully that makes sense. Let's go to the next one. Find 5 points that satisfy the equation y equals x squared. So again, we're going to start with that xy table. Okay. Start with home base. What would get the y to be equal to 0? Well, that's x equals 0 because 0 squared is 0. Okay, and then from there, I'm going to use the points around that home base, that 0. So I'm going to do 1, -1, and then I'll probably do 2 and -2. So now we have a total of 5 points. We're just squaring all those. So 1 squared is 1, -1 squared is 1, 2 squared is 4, -2 squared is also 4. So you end up with something like that. And then it says plot them and sketch the graph. Hopefully you remember that anything squared is quadratic, so it forms a parabola, like a U or an upside down U. In this case, it's just a regular U, but let's graph these out. 0, 0 is here. 1, 1 is here, -1, 1 is here. So you can already see why it forms that parabola, that U. There's a symmetry to this. 2, 4, 1, 2, 3, 4 up here. -2, 4 right there. The y's are always going to be the same for the positive and negative because they're squared, and you always end up with a positive there. So you end up with a quadratic. Hopefully you can make a parabola better than me, but that's how mine looks. Plot them, sketch the graph. Okay, you get a general idea. Is it exact? Obviously not, but does it do the job? Absolutely. All right, next thing, it says, based on the previous example, can you guess the graph of y equals x squared minus 1? So basically for this one, I'm going to label this as y sub 2 equals x squared minus 1. And then I'm just going to make another part of this table, and I'm going to call it y sub 2. And basically it's just whatever the y was, because the y is x squared, but we're minusing 1 from it. So 0 minus 1 is negative 1. This is 0, this is 0, because I subtracted 1 from each of these because of this right here. Okay, 4 minus 1 is 3. 4 minus 1 is 3 as well again. So now what you notice is it's all the same y values, it's just one less value. And because it's one less value, it just basically shifts the entire graph down. So 0 comma negative 1, 1 comma 0, 1 comma 0, 2 comma 3, 1, 2, 3, 2 comma 3, something like that. So you can actually see it's the same thing as what's above it. It's just shifted a little bit. Shifted downward 1 because of that minus 1. Okay, that's basically the transformation that happens. So it says, can you guess? Kind of a weird question without actually having a question mark there. But it's basically the guess is that it's 1 lower in all the values. So, all right, let's keep going here. All right, the next one, it says, find 5 points that satisfy the equation y equals x cubed. So we're going to have x, a line, y. Again, what gets the y to be 0? Well, x 0 cubed is 0. And then I'm going to pick points that are around that 1, or I'm sorry, around that 0. So like 1, negative 1, 2, negative 2. And 1 cubed is 1, negative 1 cubed is negative 1, 2 cubed is 8, negative 2 cubed is negative 8. So you end up with all those points there. Let's graph this out here. Let's see, 0, 0, 1, 1, negative 1, negative 1, 2, 8. So it's like somewhere up here. Negative 2, negative 8, somewhere like that. Okay, and then you just connect the dots here, and you end up with something like this. Okay, and that's what a cubic function looks like. It does say right here, important note, graphs of linear equations, y equals x squared and y equals x cubed are considered basic graphs, also known as parent graphs, or also known as parent functions as well. These are graphs that you should quickly become familiar with. So it's going to be kind of like the zookeeping part of this class, where we're basically keeping track of what certain graphs look like. So make sure you understand what something that's linear looks like. It's just a line. What x squared looks like, it's a parabola, a u, an upside down u. And x cubed, it looks something like this. So that's what basically a little blurb states. We're going to go over that in more detail later on in the class though. So, all right, next thing, midpoints and distance. Think about 2 distinct points on a rectangular coordinate system. So just imagine any 2 points on a coordinate, on an XY coordinate plane. Imagine connecting them with a line. Okay, the midpoint of that line is determined by the average of the coordinates. And that's basically the midpoint formula, is you just take the average of the coordinates. You add the x's together and divide by 2. You add the y's together and divide by 2. And basically you found the midpoint. The next thing is the length of the line segment is the distance between 2 points. Okay, so let's actually start drawing this out, maybe, have an example. So we're imagining a coordinate plane here, and we're imagining 2 separate points. So I'm gonna have 1 point here, and then I'm gonna have another point, I don't know, right here. And we connect them with a line segment like that. The midpoint between them would be this formula that we just talked about right here. Okay, so the midpoint between them would probably be like somewhere like right here or something like that. The distance between them, though, you would need this formula down here, which basically all it is Pythagorean theorem. It kind of says that right there. It can be obtained from Pythagorean theorem. But you subtract the x's and square it, subtract the y's and square those, and then just add those together and do the square root, and essentially you found the distance between those 2 points. Okay, this will make more sense when we do some examples. I'm just preloading your brain right now to see midpoints, how you find those, distance, how you find them, but let's actually do it now so it sinks in a little bit more. So this thing right here, this next problem right here, it says find the distance from 0, 0 to 4, 4. Write your answer in exact form. So distance, we're gonna have to use the distance formula. So first thing we're gonna do with the distance formula is write d equals the square root, and we're gonna subtract the x's. So 0 minus 4, or you can do 4 minus 0 is probably easier. It doesn't matter because you're gonna square it anyway, and it's gonna become positive. Okay, plus subtract the y's, so 4 minus 0 here, again 4, and that's squared as well. And we're gonna finish this square root symbol. 4 squared is 16, plus 16 is 32, so you're going to have root 32. It does say write your answer in exact form, so we are going to have to simplify this. There is a perfect square in there of 4. Actually, there's a perfect square up there of 16 as well. Let's just do that one first. So root 32 is root 16 times root 2, because 16 times 2 is 32. The square root of 16 is 4. The root 2 does not cancel or simplify in any way, so the final answer in exact form is 4 root 2. Okay, and again, because this right here cancels to 4, square root of 16. Anytime you can take a perfect square out of there, because it's a square root, you're going to want to do that to simplify it completely. 7, determine the distance between those. Okay, now these numbers are a little bit more, harder to deal with than 4 minus 0. So I'm actually going to fully write out all these steps here. So it's going to say, I'm going to subtract the x's. So I'm going to do negative 8 minus negative 11, and then squaring that, plus negative 6 minus 4, quantity squared, square root all that. Okay, from here, this is going to be 11 minus 8 is 3. 3 squared is 9. Plus negative 10. Negative 6 plus negative 4 is negative 10 squared is 100. Okay, and then we're doing the square root of all this. And you end up with the square root of 109. But it says round to the nearest hundredth, which is the second decimal place. So we're going to round the square root of 109 to be 10.44. Approximately 10.44. Next thing, it says in the example above, determine the midpoint for the given point. So we're going to find the midpoint for both of those examples. So that first set of coordinates, it's 0, 0, and 4, 4. So what we're going to do is we're going to add the x's and divide by 2. And then we're going to add the y's and divide by 2. And it kind of makes sense. In the middle of 0, 0, and 4, 4 is 2, 2. Something like that. Okay, number 7's midpoint, you'd have to do negative 11 plus negative 8 divided by 2, comma, 4 plus negative 6 divided by 2. And you'll have negative 19 over 2, comma, negative 2 over 2 is negative 1. And those are the two coordinates of the midpoints for examples 6 and 7. All right. Last part we're going to talk about is circles. A circle is a set of all points in the plane, the rectangular coordinate system, the xy coordinate plane, whose distance from the fixed point called the center is constant, which makes sense. That's what a circle is. There's a radius, and the radius is the same distance all the way around the circle. The constant distance is called the radius of the circle. It follows the distance formula that the circle of radius r centered at h comma k can be described by a standard form equation right here. It is really important to understand this part right here because this will always tell you the h and the k. In this case, the h and the k are the coordinate for the center, which is something we're going to be looking for with circles. We're going to be looking for the center. It also tells us how to find the radius, which is right there. R is the radius. So we're going to use those. We're going to use standard form to find those two things. Okay? Or we're going to use those two things to find the standard form as well. It depends on the problem. So the next thing, it says find the standard form equation of the circle with that center and that radius. So we're actually going to use the standard form equation, only we know that h is equal to 0 in this case, and k is equal to negative 1. R is equal to 4. So we're going to use that formula for the standard form, this thing right here, and just fill it in. So it's going to be x minus h is 0. H is 0, so it's x minus 0 squared plus y minus negative 1 quantity squared is equal to r squared, which is 4 squared. So we're going to clean this up a little bit. The x minus 0 is gone, so you can just have x squared plus, that's minus is just a plus, so it's y plus 1 quantity squared is equal to 16, and that is the final answer. That is completely in standard form and completely simplified. So I'm just going to highlight this really quick, and that's the answer. All right, the next thing, it says graph the circle described by that equation right there. So what we're going to do first is find what our h and k is, because that's going to find our center. So in this case, h is 2, and the k is negative 3. So that's where the center is, 2 comma negative 3. That is our center. Okay, the radius is whatever this square root of that is right there. So in this case, our radius is 3. All right, so let's try to make this circle here. First, I'm going to start with the center at 2, -3. So 2, -1, 2, 3. Right there. There's the center of our circle, and the radius is 3. The easiest way to deal with the radius is just to go up 3, down 3, left 3, and right 3 from that center. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then just kind of do your best to graph them. This is kind of hard to make a perfect circle. Even dividing it up like this, you can kind of see it's not really that great of a circle, but it's just a sketch, and that will do for it. So it's this graph described based on that. So if you notice, I had to use the standard form to figure out the center. Once I figured out the center, I also use the standard form to find the radius, and then from there, I plot my center, plot the radiuses around it, and then just try to connect the dots into a circle. Hopefully that makes sense. 11, it says the equation right there describes a circle. Write an equation in standard form and determine the center and radius of the circle. So to do this, we're actually going to be using the method that we went over before a few videos ago about completing the square. So if we complete the square on this, we'll actually have this in standard form. Right now it is not in standard form, it's in expanded form. So this is kind of involved, so make sure you definitely pay attention, pause, rewatch this part if you need to, because this is a lot. So first thing we're gonna do is I'm gonna separate all the things with X's from the things with Y's. And I'm gonna leave a lot of space here because we're gonna need it. And then I'm gonna add that 4 right here. It says right here -4. I'm gonna add it to the other side. So it's gonna look like that. So that's the first step. Separate the X's, separate the Y's. If you have any constants, just throw it on the other side. So it's -4. I added 4 to both sides. You add a 4 on the right. From here, we're gonna complete the square on this part and then this part as well. And to complete the square, all you have to do is take that B term, whatever number's in front there, just divide it by 2 and square it. So 2 divided by 2 is 1, squared is 1. Okay, plus, we're gonna do the same thing with this 4 over here. Divide that -4 by 2, you get -2. Square it, you get 4. So we're gonna add a 4 here. But if you notice, I artificially added a 1 and I artificially added a 4. So I'm gonna also artificially add a 1 to the other side and artificially add the 4 as well, just so everything's balanced. If you add something to one side and not the other, it will not work. Everything has to be balanced. Equal rights in math. All right, the next thing we're gonna go over here is we're gonna factor this here. This factors to x plus 1 quantity squared. This other part here factors to y minus 2 quantity squared is equal to 9. So now you can actually see I went into standard form just by completing the square. That's primarily the reason we even go over completing the square, is because of stuff like this. And now we can actually figure out, write the equation in standard form, so that's that. Let me highlight this real quick because this is the first part of the answer. Write the equation in standard form. The next, it says determine the center and the radius of the circle. The center is going to be at -1, 2, because there's a +1 and a -2 here. You basically flip the signs and you get the center. The radius is the square root of whatever's over here. The square root of 9 is 3. So r is equal to 3. So that is basically the center and the radius of that circle, which is what it's asking for. So that's a pretty involved video of all the stuff that we basically are going over in this section. Make sure you understand that, how to plot points, how to find points for a certain function. Make sure you understand the distance formula, midpoint formula as well, and the completing the square, super important for that standard form of equation of a circle. And then make sure you know how to graph all those. So if you have any questions about anything in this video, let me know.